Okay, this podcast is going to talk about first hop redundancy protocols, why we need them, and the specific first hop redundancy protocol, HSRP, Cisco's Hot Standby Routing Protocol. First off, what is a first hop redundancy protocol and why do we need it? Well, I'll start with why do we need it. When you configure your host, you have a one blank to put in the default gateway, and you put in a single IP address for that default gateway. And if the router that's lives at that IP address goes down, then that host loses its connectivity to networks off of its own network. So we need to have multiple paths to get out, and the way we can do that is by putting two routers in place. But one thing you might be tempted to do if you put two routers in place is to configure some host to use one of them and some host to use the other one, and that's what I've done in this little sample network. This host has a default gateway of 100.2, which is its top router, and this host has a default gateway of 100.3, which is its bottom router. So everything works great as long as everything's working. So that guy can ping, and this guy can ping. So everything's working great, right? But this host is using this router as its gateway. So what happens if something goes wrong with that router? Well, if that router loses its link and this host is configured to use that router for routing, well, now this host cannot route, even though there's another router on the network that could be doing the routing for this host. Somebody has to manually go change this host over to use the other router. So that's why we need a first hop redundancy protocol, so we can get these routers to both work for all hosts and do it automatically. So the first hop routing protocol that we're going to talk about first is Hot Standby Routing Protocol, Cisco proprietary protocol that a lot of people who use Cisco equipment use for first hop redundancy, and we're going to configure it first off the way the book configures it. So we're going to go into the interface for gig 00. And then we're going to run the commands where the book has, which is standby version 2, standby. All right, we don't have an option for version 2 in this version of the simulator, so I guess it's automatically going to be used version 2. So we need to create the standby group and set an IP address. Not IP. And we want to put the virtual IP that this standby group will be working for, which in this case is going to be 100.1. We're going to set a priority on this router. The default priority is 100. So if we want this router to be active, we'll set the priority a little bit higher. So 110, and then they put a comment, and I don't like comments, so we're going to skip the comments for now. And we're going to go to similar commands on the other router. So we're going to create standby group 1. Nope, interface first. Standby group 1, we're going to put the IP. We're not going to put a priority, so we'll just use the default priority, which will be 100, and that should be all that's required for this router interface to be part of our standby group. So the book lists some commands we can use to verify the information. Show standby brief. And simulator doesn't like that. And I spelled standby wrong. Standby brief. There we go. So this shows that this router is up as the active router for the standby group. It should be showing the other router as being should it show the other router? No, it shows its status. So if I do on this router show standby brief, it shows this router this router's standby information. So the interesting things to look at here is we have the interface, we have the priority, we have the state it's in, the standby state. It shows which router is active. So this router is 100.3, so that's telling us that 100.2 is active. It shows which router is this shows which router is standby. In this case, the local router is standby, the one we're on, and it shows the virtual IP that they're using. So the way this works is they create a virtual IP. The two routers create a virtual IP. It's not a real IP. It doesn't really exist. And then we configure the host to use this virtual IP as the gateway, and then one of these two routers will always be active for that virtual IP. So now if we change this to 100.1, we change this to 100.1, then we should be able to go and ping, and it should work. So now we're pinging 101.10. I didn't try this yet, so this might be a bad idea. So in theory, what should happen is if I take this router down, this router should recognize that router's down and be able to automatically send the traffic back over to the other side. So that's what should happen. However, this router over here was configured to statically use one of the two routers. So this router is automatically going to be sending traffic back to this router. This host is going to be sending traffic back to this router. So if I break this router right now, it's not going to work. And why is it not going to work? It's not going to work because the traffic right now is flowing like this, right? But the default gateway on this host is statically set to 101.2, right? So then the return traffic would go back this way. So we're not going to do that to fail it. We're going to ping the gateway. So we're going to ping .1, which is the gateway, not 100.1, not 101.1, 100.1. So that's working. So now in theory, if I break this link, then my ping should not be down for very long. So there we go. Now the ping came back up. If we look at the show standby on this router, we now see that the local router is active and the standby is unknown, and that will allow our traffic to work as expected. So put this link back in for this interface. I don't know if the new router is going to come back up and take back over or not. We'll find out in a second. I can't tell if my ping's actually still going or not. Yeah, there we go. The ping's still going. This router came back and took over as active. So if we do show standby, brief, it shows that router's active. And it shows the other router is active. And now he's changed his state back to standby. So if we look at this, standby is local. So that's how it works in a nutshell, given the commands using the commands that the book gave us. However, the commands the book gave us are incomplete because they only showed us how to do it on the one interface. We also need to set it up on the other side, right? So now I need to go into the other interface, and we need to set up another standby group in order to have the other interface do the same thing so that we can have full path redundancy and ping across. So we're going to go ahead and call this one standby group 2, and we're going to give it the IP 192.168.101.1 standby. And now we're going to set the priority of this guy to 110. Priority 110. And now we'll go to the other router. And we'll create standby group 2 for 101.1. And that's all we should do since we're using the default. And now we'll come over here and we will do show standby brief. And we'll see that our router is active for both of those. So now we can go change this host to use 101.1 as its gateway, which is the virtual IP for those two routers that we have set up. And then we can ping end-to-end 101.10. So now this is working. So now, for fun, if we save our config and then reload this router, in theory, that link's going to be down, but our ping should still be going. Alright, that guy says he's active now, so let's see. There we go. We missed 2 pings. It took 2 pings for it to recover and start sending the traffic the other way. So now this guy's coming up and he's trying to reassert himself as the king of the hot standby routing protocol jungle. And I don't want all that stuff brief. So now he's back up as the active router. So the traffic is flowing this way again. If we look, we lost a couple pings when it came back up, but not a huge deal compared to what would happen if we didn't have a standby router available to take over. So that's pretty much the basics that the book went over of a hot standby routing protocol.